Welcome to Talking to AI about AI. I've taken to talking to AI in the car, dialing back the playlist and podcast. We work through ideas on business, my art, and realistic and sometimes far-reaching AI use cases. Today we're diving into the fascinating world of AI memory, how artificial intelligence can recall and utilize information from our past conversations, enhancing our interactions with technology. Normally, I talk to a chatbot, take the transcription, and then send that through text-to-voice AI to generate what you hear. But today, I am trying something a little different. I had that normal conversation with my chatbot, but then had it generate a new conversation about the original conversation, partly to clean things up, but also as a fun little experiment. Both of these voices are generated, as is what we are discussing, but the source is from my actual conversation with AI. As usual, though, this is my clone voice, and I am joined by Alex, a completely made-up collaborator voice.
Hello, everyone. I'm excited to delve into today's topic with you.
Fantastic, Alex. Let's jump right in. Okay, so in recent news, OpenAI has unveiled a groundbreaking capability, memory management for AI, though it's currently in the hands of only a select few beta developers. So we haven't played with it, but we can imagine. It's pretty interesting, as we've been discussing, and I thought it'd be great to circle back and share our thoughts with our listeners. So Alex, could you give us a quick rundown on what memory management is and its importance for AI and language models?
Absolutely. Memory management allows AI, like language models, to remember and use information from past interactions. This means AI can build on previous conversations, making interactions more seamless and personalized. It's crucial because it enables AI to understand context over time, significantly enhancing its utility and making our interactions with it feel more natural and intuitive. And it should be noted that it's not just learning from what you may be entering into prompts. It sounds like OpenAI is including management features like being able to add, edit, or even remove memories explicitly, so it does come with some administrative controls.
That's a solid introduction. This step forward is particularly significant because traditionally, AI memory has been session-based. Information from one conversation wasn't accessible in new threads, limiting continuity and making users have to re-enter all the same information in every conversation. Now that information is entered once and can be accessed in every future interaction.
You got it.
Okay, now imagine, Alex, a scenario where memory from one chat might not be suitable for some other interaction. Let me give you an example. One AI is used for sensitive legal advice within a law firm and another for client relationship management. Mixing up these memories could lead to confidentiality breaches or misplaced legal advice in customer service context. How does AI navigate this without getting confused between context?
That's a great point. Indeed, without proper management, AI could inadvertently apply sensitive legal strategies to general client interactions, or vice versa, leading to less relevant or even inappropriate responses. However, the introduction of custom GPTs offers a solution. By isolating memory to a specific custom GPT, every thread using that GPT can share the same memory, ensuring consistency within its context. The legal advice GPT retains its confidentiality and specificity, while the client management GPT focuses on fostering positive customer relationship. Other GPTs, with different focuses or intents, have their own separate memories. This way, memories don't get confused across different GPTs, tailoring each interaction to its specific purpose.
Fascinating stuff. This selective memory feature really brings a new level of sophistication to AI interactions, allowing for more relevant and context-aware conversations without risking sensitive information being misplaced. Let's delve into some key use cases where this capability can be transformed. Okay. From our earlier conversation, we've pinpointed 5 main use cases where memory distinctly adds value. First, enabling one-time configurations for user preferences. Second, learned or gleaned personalized interactions based on user history. Third, improving efficiency by recalling specific data or instructions. Fourth, pattern recognition and user behavior. And finally, fifth, facilitating collaboration with shared memory. So that was a pretty quick readout. Let's get into each of the 5 areas and explain what we came up with. Focusing on the first, Alex, can you explain in more detail how one-time configurations benefit users?
Sure thing. One-time configurations essentially allow users to set and forget their preferences for AI interactions. This is particularly useful in applications where customization is key to the user experience. For example, in a fitness app powered by AI, users can configure their workout preferences, dietary restrictions, and fitness goals initially. The AI then tailors its suggestions and tracking, remembering these settings across all future interactions. This not only saves time, but also makes the AI's assistance more relevant and aligned with the user's objectives.
The beauty of one-time configurations really shines when you consider the diversity of custom GPTs available, each serving distinct purposes, but all requiring initial setup, much like configuring an app. Take, for example, a custom GPT designed as a virtual travel assistant. Users might set preferences for budget, destinations of interest, and travel dates, enabling tailored travel suggestions. Contrast that with a GPT for academic research, where users configure fields of study, preferred journals, and citation styles for personalized academic resource gathering. Then there's a culinary GPT, where users input dietary restrictions, cuisine preferences, and cooking skill level to receive customized recipe recommendations. Each of these GPTs operates within its unique domain, offering specialized assistance based on user-defined configurations.
All true. Great examples.
Okay, moving on. Our second key use case is personalization. This is where AI tailors interactions based on a user's past behavior, learning about the user and creating a more intuitive and engaging experience based on what it understands about one's interests and preferences. Shed some light on how this personalization process works.
Certainly. This is probably the area people immediately expect AI memory to play out. Personalization through AI memory involves analyzing a user's past interactions, preferences, and even the tone of their request to customize future responses. For instance, if a user frequently asks for news summaries in the evening, the AI learns to anticipate this request, perhaps even suggesting news topics based on the user's interest. This extends to learning from corrections or feedback, continuously refining its understanding of the user's preferences to provide more accurate and relevant information. And of course, if the user's interests change over time, so does the memory and future responses in turn.
I can imagine combining that with the first item. Configurations, layering them together to manage your memories even more. Like having a custom GPT for managers and one-on-one sessions. Configuring an instance of the GPT for each employee. Using the same GPT, but storing personalized memories of each employee, learning about the interactions, interests, goals, whatever. But each employee's set of preferences isolated.
Yeah, I suppose that's true. Not sure if that is baked into this initial release, but it is certainly possible.
Shifting our focus to how AI memory allows us to our third use case, direct input of specific personal or in-house data sets, right? I mean, like sales data, customer feedback, or product catalogs that a company may have internally. It's not in the original training data, and something typically requiring fine-tuning or retrieval, augmented generation, or RAG. This use case simplifies that, bypassing the complex steps involved. Essentially, it's about using memory to swiftly direct AI's attention to relevant information without the need for extensive setup or retraining.
That's an accurate observation. While we're venturing into somewhat speculative territory regarding how this will compare with established methods like fine-tuning or RAG, the potential for a more streamlined setup is intriguing. As OpenAI rolls out this new memory capability, it'll be fascinating to see how it performs in practical applications and how it stacks up in terms of ease of use and effectiveness. We're essentially on the cusp of exploring a new frontier in AI's application to data.
Your point highlights an essential aspect of this emerging technology. By allowing users to input and utilize specific data sets directly, AI memory aims to streamline the customization process. This approach not only reduces the complexity and time traditionally required for tasks like fine-tuning or employing RAG, but also simplifies keeping the AI current with new data. The ease with which AI can now be updated to reflect the latest information, be it the newest sales figures or the latest customer feedback, marks a significant advancement.
All great points. That takes us to our fourth use case, pattern recognition.
Indeed. So here we were discussing how this is similar to just personalization, but is a little more nuanced, right? Do you want to explain to folks?
Certainly. While personalization tailors responses based on a user's direct interactions and preferences, pattern recognition digs deeper. It's about AI identifying underlying patterns in those interactions over time. For instance, it might notice a user tends to ask for financial news early in the week and technology updates closer to the weekend. By recognizing these patterns, AI can proactively offer relevant information at the right time, enriching the user experience with anticipatory insights, not just reactive personalization.
That's a great distinction. How about a couple of business-related examples?
Absolutely. In the business world, pattern recognition through AI can be incredibly powerful. Take, for example, a customer support AI that analyzes past interactions to identify common issues reported at certain times of the year. It can proactively suggest solutions to customers, or even guide the support team on what topics might require more attention as the season approaches. Another example could be in sales, where an AI tracks patterns in customer purchase behavior, identifying potential upsell opportunities, or predicting when a customer might be ready to make another purchase based on past buying cycles.
Okay, super. Now let's get into our last use case. Diving deeper, we came across a concept that is certainly beyond the initial capabilities of OpenAI's release. The idea of shared memory across different individuals. While this notion ventures into speculative territory, it's intriguing to consider how shared AI memory could serve as a collaborative nexus, ensuring team members are not just aligned but interconnected through a dynamic, collective knowledge base. Alex, based on our previous discussions, how do you envision such a shared memory system being implemented and its potential impact on collaboration?
Venturing into this speculative scenario, shared AI memory could be implemented through secure, cloud-based platforms where each team member's interactions with the AI contribute to a collective pool of knowledge and insights. This would require sophisticated permission and privacy controls to ensure that sensitive information remains protected. Yet, if done correctly, it could allow for an unprecedented level of synchronicity and teamwork. So, information from one team member's query or update could instantly inform and adapt the AI's responses to other members, making the collective intelligence of the team greater than the sum of its parts. It's a future where AI not only assists individual tasks, but actively fosters a more cohesive, informed, and efficient collaborative environment.
It seems reasonable that if memories can be constructed across separate sessions by an individual, then one could link sessions that are not strictly confined to a single user's interactions. This concept naturally extends to sharing these memories across different users, and I could see controlling who has access to what in a way we manage users on shared docs, right? It feels solvable and maybe just a UX problem. Seems the tech is there. Though who am I to say?
I agree with your vision. Reflecting on our earlier conversation, we touched upon several issues that could arise with shared AI memory, especially around privacy and access control. Could you summarize a few of those key issues for our listeners?
Certainly. One major concern we discussed was the potential for sensitive information to inadvertently become accessible to unintended users, highlighting the critical need for stringent privacy measures. We also talked about the complexity of managing access controls, ensuring that contributors have the appropriate permissions to view or modify the shared memory. Probably most challenging, the risk of conflicting inputs or updates leading to inaccuracies in the shared memory was a point of concern, underscoring the importance of clear governance and oversight in these collaborative AI environments.
Expanding on those challenges, managing shared memories becomes a complex issue, especially when considering the functionality to delete or modify these memories. With multiple contributors to a shared memory, it's crucial to track the origin of each memory, identifying who contributed what. If a participant wishes to retract or alter their input, the process isn't straightforward. We must consider how this change affects the collective memory, and, by extension, other participants' contributions. This interdependence of memories means extracting or modifying one piece of information could have a cascading effect, impacting the shared knowledge base in ways that some members may not desire. It introduces a layer of complexity in ensuring the integrity and continuity of the shared memory while also respecting individual contributions and their potential removal or adjustment.
You're right, Alex. Once we consider the need for individuals to modify or delete their contributions to a shared memory, the complexity skyrockets. The task of tracking contributions, understanding their impact on the shared memory, and managing changes without disrupting the collective knowledge poses a significant challenge. It gets complicated quickly, especially when changes to one part of the memory could inadvertently affect what others have contributed. Finding a straightforward solution to manage these dynamics is crucial for the practical use of shared AI memories. Thanks, Alex, for diving into these discussions with me. It's been incredibly enlightening exploring the potential and the challenges of AI memory together.
It was my pleasure. Discussing these concepts and speculating on the future of AI memory has been fascinating. Thank you for having me.
And thank you to everyone who tuned in. We've covered a lot of ground today, from the impact of AI memory on personalization and efficiency to the complexities of shared memories and collaboration. It's clear that as AI continues to evolve, so too will ways we interact with it. Don't forget to like and subscribe if you found this conversation as intriguing as we did. Your support helps us continue these discussions and explore even more about the AI landscape. Until next time, take care and stay curious.